Right, welcome to paper number 17, brought to you by Mr. Graham, and we'll get straight into question 1, which is a distance time graph. So the first thing we should really notice is read the question at the top about Mary walking from her home to a cafe and back. And you can see from the graph we've got the home mentioned here, and then this is the distance as we go up, all the way up to the cafe from home and back. So the first question we're asked is, how far does Mary walk altogether? And that's a fairly straightforward question because basically she walks to the cafe, which is 6 kilometers away, and she walks back again, which is 6 kilometers back. So the answer is 12 kilometers. We then go off to say Mary sets off at 9 AM. What time does she arrive at the cafe? Now, the time she arrives at the cafe is 2 hours, and I'll just mark that 2 hours from the start. So here really, so 2 hours from the start, so 2 hours after 9 AM, and 2 hours after 9 AM is 11 AM. And the last bit is about average speed on the way back from the cafe. Now, a bit of a clue for average speed. Speed equals distance divided by time, but a lot of the time in these questions, what you really need to think is, what distance was travelled in 1 hour? Because distance travelled in an hour is distance per hour, or the speed. Okay, speed is distance per hour. So if we look the cafe up here, so at the very top, the cafe, and in 1 hour, which is from 3 to 4, this is the path that's travelled, and that is from 6 kilometers away to 2 kilometers away, which is a total of 4 kilometers. So in 1 hour on the way back, 4 kilometers is travelled. So that is 4 kilometers per hour. Okay, so the answer, as we write it in, is 4 kilometers per hour. Alright, so just looking back at that, it's a sort of a bit of a shortcut to getting the answer. Just in 1 hour, what distance is travelled? It's from 6 kilometers away to 2 kilometers away from home, so that is 4 kilometers between them, 4 kilometers per hour. Of course, you can do that question by doing speed is distance divided by time. And distance travelled there is 6 kilometers divided by the time taken. The time taken is 1.5, 1.5 hours, 1 hour and a half hour, and that also equals 4 kilometers per hour. Question 2 is all about the properties of shapes, quadrilaterals, and what we need to do is complete the table showing the properties of some quadrilaterals. So if we look at the table, the parallelogram is filled in for you. It is both pairs of opposite angles equal, all sides it doesn't have equal, and diagonals do not cross at right angles. So let's first of all look at the trapezium. It says both pairs of opposite angles equals, that is false. All sides are equal, that is also false, and diagonals do not cross at right angles. Basically a trapezium has one property, and that is that opposite sides are parallel. So here, this side and this side are parallel. That's the only real property the trapezium has. Going on then to a kite. A kite has both pairs of opposite angles equal. That is not true. It actually has one pair of opposite angles equal. This angle and this angle here are the same. Okay, but in this case, the top and the bottom one are not the same. The top one you can see looks obtuse and the bottom one looks acute. All sides are equal is also false. And the reason for that is you can see this actually has this and this side of the same length, and this and this side of the same length, but all sides are not equal. And the final property there is a property that you need to know, is that the diagonals do cross at right angles. Okay, the diagonals do cross at right angles. And a diagonal is, it's not necessarily a line that goes at a slant, it is a line that joins two corners together. So you can see there, they join at right angles. So a diagonal is not, okay, it is not a line that goes like this. It is a line that joins two corners or two vertices together. Going on to the second bit then, we've got to name a quadrilateral that both pairs of opposite angles are equal, all sides are equal, and diagonals cross at right angles. And we have two answers for that. We can have a square, and we can have a rhombus. So a square or a rhombus. Actually, a square has all angles equal. So a rhombus has both pairs of opposite angles equal. A square essentially has an extra property on top of that, that all the angles are equal. And both of them have diagonals cross at right angles. And for a lot of the time, it's the diagonals crossing at right angles. There's really only 3 shapes where the diagonals cross at right angles, which is a kite, a square, and a rhombus. So that's something you should try and learn. Diagonals crossing at right angles, and also understanding what a diagonal is. It's not necessarily a line at a slant, but a line that joins 2 corners together. Question number 3 has in the top corner here this star, which means how you set your work out is important. You need to be clear. So you can't just make your work go anywhere you want. You need to be clear on how you set it out. So if we start with reading the question. So the first thing is a raffle has 3 prizes. First prize 40, second prize, third prize you're given information about. So you told what all the prizes are. You're told what raffle tickets cost 50p each. And you need to know how many tickets are sold to make a profit of £70. So your outgoing costs are the prizes, okay, and your incoming costs are whatever you sell the tickets for, and you need to make a profit of £70. So the first thing to do would be to actually just write first prize, basically. Okay, so first prize is 40. Write what the second prize is, and the second prize is 3/4 of the first prize. So 40 divided by 4 is 10, and times it by 3 is 30. And the third prize is half of the second prize, which is 15. So the total prize money available, adding those up, is £85. So it's £85 is what you have to spend on prizes, and you want to make a profit of 70. So really what you need to do is you need to make 70 plus 85 out of raffle tickets, £155 of raffle tickets, to cover the cost of the prizes and your profit. And if they cost 50p each, every pound gets you 2 raffle tickets, so it's 155 times it by 2, and 155 times it by 2 is 310 raffle tickets. Question number 4. The average speed of a car is 50 miles per hour, and the journey is 400 kilometers long. And I guess what the most important thing for you to notice here is we're dealing in miles per hour, but the journey is kilometers. So really it's a matter of saying, okay, we've got miles per hour, we've got distance in kilometers. This involves some kind of conversion. There's 4 conversions you need to know, one of which is between miles and kilometers, and the conversion is 5 miles is 8 kilometers. So really that's what we're going to work with. 5 miles is 8 kilometers. Whichever way we're going to change it, we need to use that fact. So we could either change the 50 miles per hour into kilometers per hour, or change the 400 kilometers into miles. And looking at it, probably the easiest thing to do is change the miles per hour. If 5 miles per hour, okay, you know 50 miles per hour, so it would be times it by 10. So really 50 miles per hour would be the same as 80 kilometers per hour. Okay, so you're really going at a speed of 80 kilometers per hour. And then the question is, do you know how to do speed, distance, and time? So you should know speed is distance divided by time. And you should know that because kilometers per hour means you're doing kilometers divided by hours, or miles per hour means you're doing miles divided by hours. In this question, because we need to know the time, we need to rearrange that formula. Alright, so to rearrange that formula, times both sides by t, so that's time times speed equals distance, and then divide by s, t equals that's d divided by s, so distance divided by speed. So the total time taken is 400 divided by 80, and 400 divided by 80 is 5 hours. Okay, so a question like this is involving averages, mean, median, and mode. Mode is the most common, median is the middle, and the mean is all the different answers added up divided by how many different answers there are. In other words, you're sharing out all the values between everything. A question like this, please make sure you give an answer to, please make sure you try, and even if you're not quite sure what you're doing, make a guess and try lots of different things until you get there. So be persistent with it. When it says work out 5 numbers, what you should maybe do is give yourself room to write 5 different answers and think of it as lines where I'm going to put on 5 different answers. You're told the mode is 3, which means there must be at least 2 3s. Right? There must be at least 2 3s, maybe more. The median is 7, so the middle is 7. So already we can see if it's 2 3s and a 7, and the middle is 7 and there's 2 3s, then it's really the last two numbers we don't know. We're told the mean is 6. Now one thing to know is if the mean is 6 and there's 5 numbers, what that means is we have 6 times 5 equals 30. The numbers add to get 30. Because if you add the numbers up and divide it by 5, you get 6. So in reverse, if each of the numbers averages out to be 6, the mean to be 6, then if you do 6 times 5 tells you they add to get 30. Now so far, these numbers here add to get 13, which leaves these two up here to get 17, to make up to 30. So we need to add those to get 30, so when we divide by 5 we get 6. So two numbers that add to get 17, that might be the same as 7 or bigger than 7. Well, the most straightforward thing to do would be to pick 8 and 9. Another two numbers that could add to get 17 would be 7 and 10. The only problem with 7 and 10 would be the median would still be 7, but the mode would then not just be 3 anymore. So once you get the answers, fill them in 3, 3, 7, 8, 9, and check it's correct. Right, number 6 is about the area of a trapezium, and the area of trapezium formula is at the front of the paper. There's a formula for the area of a trapezium, which is half A plus B times H. And the key thing to know, A and B are the parallel sides. A and B are the parallel sides. They don't have to be the horizontal sides, they're the parallel sides. And H is the perpendicular distance between them. So in this case here, what we have is half of 5 plus 9 times it by 4. 5 plus 9 is 14. Half of 14 is 7, so it's 7 times 4, which is 28 centimeters squared. Alright, what we have is a scatter diagram, and the scatter diagram shows a relationship between two things. So it's a relationship of cost and distance for 10 coach journeys. So every X represents 2 bits of information about one coach journey. So for instance, the first one here, this one here, represents a coach journey for 50 miles and a cost of, I think, about £12. So each X represents one coach journey and two things about it. And it's really about finding a relationship between the two. So a line of best fit is the idea that is there a line that you can draw that sort of goes through the points, with the points as close as possible to the line. So it's sort of somewhere, I suppose, something like that with your ruler. And what you hope is, which is what I haven't been able to do there, is that most of the points will be shared out. Like here we have 3 points above the line, but only 1 beneath. What you would hope is that the points really are as close as possible to the line with the same amount sort of above and below, and it doesn't have to go through 0, 0. So there it's totally okay that it goes through that. So you'll use your ruler and do that as best you can. That's a sort of rough idea. One thing you can do is lay your ruler on top so it covers all the points to get the rough direction. So you wouldn't want a line that sort of looked like that. That's not the direction of the points. So make sure that when you do it you don't have a line that looks like that. Okay, so we'll take that one out there. Now, that's our line of best fit. It says estimate the cost of a journey of 175 miles. So you need to go to 175 miles and carefully, using your ruler, go up to the line, mark it on the graph with a ruler, then go across with a ruler carefully until you get the answer and read it off carefully, and I think you should get about £30. Now it depends on your line, and what will be marked correct is how you've marked it on your line. So please make sure you mark it on the line and you read off the value that you've been given. The last part, it says the scatter graph shows positive correlation. Explain what this means for the relationship between the cost and the distance of a journey. So you need to write something like, as the distance increases, the cost increases. So the longer the journey, the more expensive it is. So that's what you need to write at the bottom for that question. As the distance increases, the cost increases as well. So question 8 is about an arrowhead drawn inside a square. You're given the measurements of the square, it's 6 centimeters around the side. You're told some information about the midpoint, so X is the midpoint of one side, so that's the midpoint of that side, and Y is the center of the square. And as usual, there's information, if it says not drawn accurately, you don't need to measure it, it's all about using the figures that are given. And it says work out the area of the arrowhead. Now one thing to know, an arrowhead is basically a type of kite. So in this question here, what we really have is that we've got a kite, these two sides are the same length, these two sides are the same length, and these angles here, there's one pair of angles that are the same, so those angles are the same. So it's really a question about a kite. Now for some of you that might help you get the answer, because the area of a kite is the two diagonals multiplied together divided by 2. So the area of any kite is the multiplication of the two diagonals divided by 2. So in this question here, what we have is that one diagonal is this bit here. And remember from earlier, a diagonal joins one corner to another corner. It doesn't have to be at a slope. So the line joining xy is the length of one of the diagonals, which is 3 centimeters. And the other diagonal is actually this line here along the bottom. So another thing about diagonals, it does not have to be inside the shape. It just literally joins one corner to another corner, either inside or outside the shape. So that length there is 6, so it's the two diagonals multiplied together is 3 times 6 and divided by 2. So it's the two diagonals multiplied together, which is 18, divided by 2, which is 9. So the answer is 9 centimeters squared. So an arrowhead is basically a kite. One thing you might know is, right, if you didn't notice that, you might have seen the problem slightly differently. You might have seen it as a big triangle, and there's our big triangle there. Take away a small triangle, and there's our small triangle there, which leaves you with the shaded bit. So the area of the big triangle would be base times height divided by 2, which is 6 times 6 divided by 2, which is 18. Take away the area of the small triangle, and the small triangle, the base is 6, times it by the height, the perpendicular height is 3, divided by 2, base times height divided by 2, which is 9. And 18 take away 9 is of course 9, which is the answer we got. So there's just two ways to look at the same question, and maybe something you might have learnt there is that an arrowhead is a type of kite. And you might also have learnt a wee bit about the diagonals of a shape being either inside or outside the shape joining two corners, but a side of a shape is not a diagonal. So there's just two diagonals for that shape. Question number 9 is about highest common factors and lowest common multiple. A factor of a number is a number that divides into it. So the factors of 30 are 1 and 30, don't forget about 1 and 30, 2 and 15, 3 and 10, 5 and 6. And a question like this worth only 1 mark, it does seem that it can't be that difficult. So in this question you maybe might just recognise the highest common factor is 10. That is the biggest number that goes into both of them. So for 30 it has a higher factor of 15, but 15 doesn't go into 80 if you check. 15 fives are 75, and 30 doesn't go into 80 either, so 10 is the highest common factor. For the least common multiple, there's a couple of ways to do it, but for a question like this worth only 2 marks, there's no mention of prime factors anywhere. The easiest thing might be to take the biggest number, and it's always easier to take the biggest number, and just write out the multiples of 80, and that's just really the times tables. Just keep adding on 80. So do that a few times and then think about 30. So you have 30, 60, 90, 120, 150, 180, 210, and eventually 240. So always write a couple out for the biggest one and then think about the smallest one. So the answer is 240. The alternative way to do that question is to write out 30 and 80 and write out what 30 and 80 are as a product of primes. So 30, if you divide it by 2, is 15. Divided by 3 is 5, and divided by 5 is 1. So it's 2 times 3 times 5. And 80, if you write 80 out, it's an even number, so divide it by 2. Just keep dividing it by 2 until it is no longer even. So we can divide it till we get down all the way down to 5. And we have 2 to the power of 4 times 5. So you could have used that to find out the answer to both A and B. Because firstly, the highest common factor, if we go back to the first bit, the highest common factor is basically the factors they have in common multiplied together. So they both have a 2 and they both have a 5, so that's 2 times 5. But for least common multiple, you need to include all the factors. So you would have 2 to the power of 4, so the highest power of 2, the highest power of 3, and the highest power of 5. So they both have a 5 to the power of 1. And if we do 2 to the power of 4, which is 16, times 3 is 48, times 5 is 240. So that would be an alternative way to do the same question. And sometimes it depends upon how the question's asked. If you've been doing prime, product of primes, then maybe that's the easiest way to do it. Number 10, Ellie has 3,000 songs on her MP3 player. On Monday, she listened to 50 songs chosen at random and 15 were rock songs. So it's really giving you a proportion of the songs that she chose that were rock songs. And it asks you to estimate the number of rock songs on her MP3 player. So essentially what you're sort of understanding is that there is 15 out of 50 in the sort of sample that she took. But we have 3,000, so we really have to work out what proportion, what would that be if it was out of 3,000? Or another way to say it is that fraction of 3,000. So if we're working out that fraction of 3,000, one thing you might do is to simplify it a bit. 5 goes into that 3 times, 5 goes into that 10 times. And the same here, 10 goes into that once, and that 300 times. So it's 3 times 300, which is 900. So 900 of the songs. On Tuesday, she again listened to 50 songs chosen at random, and 10 were rock songs. Give a reason why the number of rock songs was different each day. It's almost so obvious to write this down, but basically because it is at random. There's not really any other way to say it. The songs chosen are at random, so every day it's going to be different. Right? It's not going to be exactly in the right proportion because it's at random. Number 11, an algebra question. Make x the subject of y equals 2x plus 3. So this is a formula, and if you're asked to make something the subject, presently the subject is y, and that is what is by itself. So really what you're being asked to do is make x be by itself. So really use the rules of algebra. So the first thing is to get the 2x by itself. So to get 2x by itself, you need to take away 3 from that side and also from the other side. So that gets you y take 3 equals 2x. And then the next thing to do is to get x by itself. And to get x by itself, you need to divide that side by 2 and then the other side by 2 also to keep it the same. So it's y minus 3 over 2. So the answer is x equals y take 3 over 2. Number 12, write down the value of, so this is a test of your indices. Have you learnt that 2 to the power of 0 does not mean the answer is 0? Anything to the power of 0 is 1, so 2 to the power of 0 is 1. 7 to the power of 0 would be 1, etc. Have you learnt that a negative power does not mean a negative answer? A negative power means a fraction. So in this case here, 2 to the power of minus 1 means 1 divided by 2 to the positive 1. And 2 to the positive 1 is just 2. Following on to 12b, it says work out the value of 2 to the minus 1, which is a half. We've just worked that out. And 2 to the minus 2, similarly, is 1 over 2 to the positive 2. So a negative power does not mean a negative answer. A negative power is to do with fractions, and 1 over 2 to the power of 2 is 1 over 2 times itself, which is 4. So a half plus a quarter get a common denominator. So the common denominator is 4, so it is 2 quarters plus 1 quarter, which is 3 quarters is the answer. Number 13, draw the region defined by the inequalities and mark the region clearly with an R. In a question like this, you're basically being asked to draw some straight lines, decide which side of the straight line shows the inequality, and then you should be left with an area somewhere in your diagram. So you're asked to show where x is bigger than or equal to 1. What you have to do is draw where x equals 1. Right? X equals 1 is a vertical line, right? A vertical line joining up all the places where x is 1. And it's a solid line because it's a greater than or equal to. So that's x equals 1. And one side of that line is less than, and one side of that line is more than. So it's to the right of it is where x is bigger than 1. So the wrong side, I'm just going to shade away the side that is incorrect. So you draw the line where it equals it, but you're sort of deciding it's the right hand side of the line is the correct bit. That's all the places where the x coordinate is bigger than 1. The second one is to show where y is bigger than or equal to x, so we have to draw where y equals x. And you should know y equals x is a line joining 0, 0, 1, 1, 2, 2 that goes through those points as best you can. Mine's a wee bit wobbly there, and that's y equal to x. How do you know where y is bigger than x? Well, all you need to do is test a point. So for instance, you check this point up here, which is 2, 6. Is the y coordinate bigger than the x coordinate? Yes, the y coordinate is 6. And it's bigger than the x coordinate, which is 2. So above the line is correct, so we're going to shade away and say this bit is incorrect. So far the area we've got is the area just there that's left unshaded. The last bit is to draw where x plus y equals 6. So to shade x plus y less than or equal to 6, show where it equals 6. Now, if you have x and y on the same side of the inequality, the easiest points to pick are let x be 0 and find y. So if x is 0, y is 6. And let y be 0, and if y is 0 in this case, x is 6. What you need though, for anything that is not x equals a number or y equals a number, you need some points to plot. So the points are that we're going to plot are 0, 6, which is here, and 6, 0. So if we join those up, and again carefully as best you can, join those up, and that's the line x plus y equal to 6. But we need to show the area that is correct. So once again, look at a point. If you even look at 0, 0 right down here, is 0 plus 0 less than or equal to 6? Well, yes, 0 plus 0 is less than or equal to 6. So the areas underneath the line are correct. So the areas that are wrong are above the line. And of course, you have to finish by saying the correct area is the bit that is left, which is there, and mark it with an R. Question 14, solving an equation. You have to be flexible when you're solving equations with fractions. If there is two things that have a denominator and the denominators are different, there's a couple of ways you can do it. So I'm going to show you one way. Basically or essentially, you want to get rid of the fractions and then end up solving it. So to do that, probably the easiest thing to do is get a common denominator, and in this case that is 6. So if you get a common denominator of 6, you have to multiply the bottom of the first one by 3, so therefore you have to multiply the top by 3, and just put it in brackets and come back to that later, 3 times x minus 1. And for the second one you have to multiply the bottom by 2, so it's 2 times the top as well, which is twice x plus 3. So I've done the same to the top and bottom of each fraction, and therefore I haven't changed their value. The next thing to do would be to multiply both sides by 6 to get rid of the fractions, and if you multiply that by 6, that becomes 3 times x minus 1 plus 2 times x plus 3, because basically you're getting rid of each of the divides by 6, but don't forget that you've got to multiply both sides by 6, so 1 times 6 is 6. And from this point it's a matter of multiplying out the brackets. So multiplying out the brackets is 3x, take 3, plus 2x plus 6 equal to 6. Now, just stop at this point before we go on. What you're told to do is do the same to both sides. When you see, however, before you do that, one thing that you should try and do, so this is an important point here, is to try and collect terms on the same side. So if you have a 3x plus a 2x, before you do anything else, you should collect those together, which should be 5x. So collect together like terms before you go ahead and start manipulating both sides. So on the same side there, minus 3 plus 6 is plus 3. So then you've got it down to sort of a problem you should be familiar with. So you should now know you need to take away 3 from both sides, and that gets you 5x equals 3, and then to get rid of that times by 5, divide by 5. And don't forget, fractions are your friend, so 3 divided by 5 is literally just 3/5. So the answer is 3/5. Question 15 is to do with sequences. So don't let it put you off that you have pictures instead of just numbers. Take your time, read the question and see if you can work out what it's about. It's about sequences. And we're asked to work out an expression for the perimeter of shape n. And each sequence of shapes is made from centimeter squares. So why don't you just take each shape in turn and find the perimeter, and then see if you can work out an expression for the perimeter of shape n, which is really asking you for the nth term. So if you realize you're really being asked to find the nth term formula, so you need to go through each shape and find the perimeter. Perimeter of the first one is 4. If you keep going and check the perimeter of each of the next ones, it's 10, followed by 16, followed by 22. So really you're being asked to find out the sequence 4, 10, 16 and 22, and hopefully you can see that it goes up 6 each time, so it's plus 6 and plus 6. And really what you're being asked to do is create a formula that tells you how to get from the position to the number. So what do you do to 1 to get 4, to 2 to get 10, 3 to get 16, and 4 to get 22? And the plus 6 helps you because it is actually telling you need to times the position by 6. So the first part of the answer is 6n. You're taking the 1 and you're timesing it by 6. However, if you times 1 by 6, you get 6, and we want to get 4. So to get 4, we need to take away 2. So let's check that works. We do 6 times 1 is 6, take away 2 to get 4. 6 times 2 is 12, take away 2 to get 10. 6 times 3 is 18, take away 2 to get 16. So one of the most important things to remember there, and this is an important point to remember, is the plus 6. Alright, this plus 6 does not mean there's a plus 6 in the formula. It tells you it is 6n, or 6 times the position, and then you add or subtract something. So maybe get comfortable with the idea that you maybe have to make up the numbers for the sequence, or do it from a pattern of shapes, and then just turn it into the problem. Question 16 is simplify fully this expression. When you have a fraction with algebra in it and you're simply asked to simplify it, so there's no equal sign, you're not asked to solve anything, it's really a matter of simplifying it like a fraction. And if you simplify a fraction, if you think of a normal fraction, what you're doing is cancelling factors. Like if I had 6 over 10 and you're asked to simplify it, you basically say the top line is 2 times 3, the bottom line is 2 times 5, and you're cancelling a factor of 2, and you're saying it's 3/5. Well, you're employing the same strategy in this. So what you have to realise is this question is asking you about factorising. So when you see a problem like this, factorise the top, factorise the bottom, and then cancel factors. Factorising really means writing it as a multiplication. So you're really doing the same technique as here. You're writing it as a multiplication and you're cancelling factors. So can you see that the top line is the difference of 2 squares? It's the only time when you have 2 terms that you end up with 2 brackets. So 2 things that are squared, x is squared and 36 is 6 squared. So x squared is at the start, so the x's go at the start of the bracket. 36 is at the end, so 6's go at the end, and you have 1 plus and 1 minus. And if you factor the bottom, the only factor you can take out is a 3. There's 2 terms, so it's 1 bracket, and it's that there. And pretty much always there'll be something that will cancel. So you shouldn't be surprised the top has a factor of x plus 6, and so does the bottom. And really you've employed the same technique. So the answer is, if you simplify it fully, it is x takes 6 over 3. And you can't simplify it any further. Alright, you can't simplify, divide top and bottom by 3 or the 6 by 3 unless it is a factor of the whole line. So this question is to do with angles and making equations for angles. So if we look at, we have PQR is a straight line. So we have a straight line here, PQR, and we know the angles in the straight line add to get 180. So we have that y plus x plus 60 is 180. So just be comfortable forming an equation with some algebra. If there's algebra in it, we shouldn't be surprised that maybe we have to form an equation and take away 60 from each side, so y plus x equals 120. And that gives us really our first equation. So the two things, y plus x, add to get 120. The second picture here, it's a parallelogram. Now, a parallelogram has various properties about angles, one of which says that opposite angles are the same. But really here we don't have opposite angles, but what we need to know is parallelogram has parallel sides, hence the name. And if it has parallel sides, we should be aware of interior angles. Therefore, those two angles add together to get 180. So a second equation can be formed, which is y plus 50 plus 2x minus 40 equals 180. And here's something to be careful about. When you have things you can collect on the same side or simplified, do that before you do anything else. So you have y plus 2x and plus 50 take 40 is plus 10 equals 180. And then to simplify it, you can do the same thing to both sides, which is to take away 10 from both sides. And if you take away 10, you get y plus x is 170, and that gets us a second equation. So really our problem is to solve those simultaneously. Alright, solve those two simultaneously, and I left out there, so that's y plus 2x equals 170. So as we do that, let's write those above each other, so we're more familiar to see it this way. And there's two ways we can do it. One of which is by substitution, and one of which is by elimination. I'm just going to do it by substitution. By elimination, because that's the way most of us are familiar with. So what I'm going to do is just change those two equations, or maybe just change one of them, to eliminate the variables. And you can eliminate either y's or x's. So in other words, you can make them both 2x, or here they're already both y. So what a number of you will have been taught is to make one a plus y and one a minus y. So I'm going to multiply the bottom one by minus 1. So the top one stays unchanged, y plus 2x is 170. And the bottom one, if you multiply by minus 1, is minus y, take x, equals minus 120. And once you do that, when you add those two together, okay, so when we add those two equations together, the y's eliminate, whereas the y's cancel out, and you're left with 2x minus x is x. 170 add minus 120 is the same as 170 take 120, so x is 50. So the answer is x is 50, and if you look back, if x is 50, if you look back, put it into one of the two equations, and this is the easiest one. If x is 50, y plus x is 120, so y must be 70. And of course, take your time to check that answer. Question 18 is about shapes. You've got a cone and a hemisphere, and are joined to make a toy as shown. They both have a radius of r. They both have a radius of r, and that's important. So for the cone, from the centre to the outside, the radius is r, but that's also the same radius of a sphere, or the hemisphere. So a hemisphere is half a sphere, and the radius is the distance from this centre point here to anywhere on the outside. That means that's r, that distance is r, that distance is r. So the radius is anywhere from that very centre bit there to anywhere on the shell, really. The volume of the toy, we've got to work out the formula for it and simplify and leave in terms of pi. So we don't need to get the calculator out, we just need to use our formulas correctly. And the formulas are at the front of the book, and really the key thing is to know the height of the cone. So as we just talked about, the radius of the sphere is r, which means that distance there is r. And if the whole height is 4r, that means this height here is 3r. So 3r plus r is 4r. So understanding the radius of the hemisphere means that that's r and that height is 3r. So we know the height of the cone, which means we can now answer the question. Right, so if we fill this in, what we really have is the formula for a hemisphere is half of that of a sphere. So if you look, the volume of a sphere is 4/3 pi r cubed. We want half of that, which is 2/3 pi r cubed. And for a cone, it is 1/3 pi r squared, and r squared times h, but h is 3r. So everything is in terms of r and pi. So simplifying that with this one here, just leave it alone, 2/3 pi r cubed, and we have r squared times r, which is r cubed here, and we have 1/3 of 3, which is 1, so that's just pi r cubed. So really what we have is 2/3 plus 1, which is 1 2/3, or 2/3 plus 3/3, so 2/3 plus 3/3 is 5/3, so the answer is 5/3 pi r cubed. And it's about having the confidence to think that looks appropriate as an answer. And you've simplified it as far as possible. You've left pi in your answer. And the main thing is you've gone back and sort of checked, does that make sense? Have you got the right height? Have you got the right radius? Have you answered the question carefully? Question 19 is an algebra question. Right here, at the end of the question it says prove this result algebraically. So once you've read all of this and it says prove the result algebraically, you need to read back over it. So it says choose two numbers, for example 8 and 5. Subtract the smaller from the larger, so 8 take away 5 squared, so 8 take 5 is 3 and 3 squared is 9. Square the numbers and add together, so the original numbers 8 and 5, if you square them, 8 squared plus 5 squared and add them together you get 89, and the difference between the two, between 9 and 89 is 80. And it says the result is 2 times the product of the original numbers are 8 and 5, and 8 times 5 is 40, and times it by 2 is 80. So we've shown it for two numbers, but it says algebraically. So algebraically means you're going to need to call the two numbers, say, x and y. So the two numbers are x and y. And what you're being asked to do are just follow through the same steps. So we've chosen two numbers, x and y. Subtract the smaller from the larger. So let's say that y is the larger one. So y take away x. We're going to subtract them and square the result. So I'm just doing exactly the same as up here. So I'm doing y take x squared. And if we do that, if we just simplify it, so it's y take x times y take x, which you're understanding that a bracket squared means that, and we're going to do y times y to get y squared, minus xy is minus 2xy. And lastly, you have minus x times minus x, and don't forget two negatives multiply to get a positive, and x times x is x squared. So really leaving that, we go on to the second stage, which is square the numbers and add. So the original numbers are x. If we square x, and if we square y and add them together, we get that expression. So we really have two expressions. Our expressions are y squared minus 2xy plus x squared and x squared plus y squared. And really you should see they're almost the same apart from one bit. It says work out the difference of the two results. Now the difference between the two things is 2xy. Right? So the difference between them is 2xy. Right? So in other words, if I take y squared minus 2xy plus x squared, and if I add 2xy, I get that there. So the difference between them is 2xy. And therefore we've got the result should be 2 times the product of the original numbers. Okay, and if we look down, 2xy is the product, okay, of the original numbers, or is twice the product of the original numbers, is the product of the original numbers. Product of the original numbers times it by 2. Okay, and that's us proved algebraically. So it's follow through the same steps as best you can, do the algebra, see what you get, and be persistent and don't give up. Last question is a probability question. If you've taken your time to read it, you'll realise here it's to do with probability. And the key bit here is without replacement. So with or without replacement will change how you do it. So a bag contains x apples, 2x oranges, 1 banana. 2 items are selected at random. If it says 2 selected at random, imagine you select one, don't replace it, and select another one. So when it says 2 are selected, always do one at a time. Pick one, don't replace it, pick another one. And the probability of selecting an apple followed by an orange is 5/23. So it's really asking you to do your best to set up an equation to work it out. So the probability of picking an apple first, there's x apples out of a total of x plus 2x plus 1, which is 3x plus 1. So that's the amount of apples divided by the total amount of fruit. So that's x is the amount of apples divided by the total amount of fruit, which is 3x plus 1. That's the probability of picking an apple. Followed by an orange, you should remember that probabilities in succession means you multiply them, something followed by something else, like along a tree diagram. And because you've taken one out, you now only have 3x fruit to choose from. So 3x plus 1 goes down 1 to 3x. But you still have 2x oranges. So the probability of picking an orange with your second pick, there's 2x oranges out of a total of 3x. And those probabilities multiply to get 5/23. And that's really your equation that you have to solve to find x, and x is the number of apples, which is what you're being asked to get. Okay, you're being asked to find x really. So you should notice that you can simplify that there, cancel the x's, and your problem really then becomes 2x, 2 times x on the top, 3 times 3x plus 1 on the bottom, equals 5/23. So that's your problem to solve. So now you've broken it down into a simple algebraic problem, which still has its difficulties. If you have a fraction equal to a fraction, and only in this case, a simple way is to cross multiply only if it is a fraction equal to another fraction that you're solving. So in this case, 2x times 23 is 46x, and 3 times 5 is 15 times 3x plus 1. Multiplying out that bracket, we have 46x equals 45x plus 15, and taking away 45x from both sides gives us x equal to 15. So the answer is x equals 15, or there are 15 apples in the bag. So there's quite a lot to that question, and quite a lot of places you could go wrong. So take your time to go back over it and do your best to make sense of it.